Hi, morning everyone.
Good
So
morning.
today we'll start from where we left yesterday. So let's get going right away. First, we will talk about concatenation. Concatenation primarily means joining two different lists. So let's define two lists. List one, we will say, let's say Sam, Gina, give some numbers. And we will call list two again as and concatenation. There are multiple ways of concatenating or joining two different lists. We will see a few more methods a little later, but one simplest way is I'll just join these two lists with a mathematical operation. And let's print out list 3. Yeah?
Got it.
We already covered this yesterday, but I am going to repeat this. I can repeat this list as many number of times. So the syntax is very simple. You type the list name here, you do the star, which is for multiplication, and the number of times that you want to repeat it. So I can do this, I can do this. That's for repetition. Now, one more thing which we saw yesterday, and we quickly go through it again, which is check membership of an element in a list. So let's take list 1 from above and let's check whether we have, say, Kevin in list 1. Let's try one more and check whether we have Gina in list 2. And let's do one more. Print 15 in this one. So the syntax is very clear. The first element that we're typing, whether it's string or it's numerical, we are checking whether that belongs, whether it has a membership in this data object. Yeah, very intuitive.
Correct.
Okay. Now there's a very important concept, which is iteration over list items. And this is something extremely useful. It will help us later in terms of iterating over very, very long data frames, long tables, 10,000 rows, etc. So the syntax is very intuitive. I'll just explain in a second. For X in list 1, print X. So what the syntax is saying in intuitive English is for every item, and we can define that item as, call it anything. Or rather we'll say denoted by any letter or a word. For every item in the data object, do the following. Following is what appears after the colon. So for every X, so every element in this one, I'm saying just print out that element. That's how it goes. And we can do just about anything, I can here say that print, let's say X, and with every X press high, print high. So we'll get this. So we can make it do pretty much just about anything. The important thing is the whole iteration, which is iterating item by item in that particular data object. And that is the syntax. For item, which is denoted by X, in the data object, do the following. All right. Let's append item in a list. Let's print this one. Okay, now I will say in list one, I want to append an item 33. And now I will again print this one. So when I do an append, it adds the appended item at the end of the list. We can even append a full list to an existing list. So let's try it here. Okay, let's print out the two lists which we already have. Print list one and print list two. These are two lists we have. Let's try to append the second list to the first one. So what I will do now is list one dot append, and I'm passing a full list. Now that this will modify list one. Let's see what is list one now. Yeah.
Yeah.
So similar to append is something called insert items in a list. We can insert. Now I'll tell you what the difference is, and then we'll run an example. Append method only works for addition of elements at the end of the list. For addition of elements at the desired position or index level, we use insert method. Insert method is used. So, unlike append, which takes only one argument, which is the item, insert requires two arguments. First will be the position or the index, and second the value. So this is very intuitive. So append allows us to add an item, but that item will by default be added at the end of the list. In insert, we can choose where we want to insert that element in the list. We can choose the index. So let's see how this works. Let's print a list 2 that we defined earlier. So this is our list 2. Now in this list 2, I will insert at, let's say, third index level or third position. I want to insert, let's say, number 51. Let's print out list 2 now. So now we see 51 is inserted where we wanted, which is index 3. So this, I believe, very clear and intuitive, the difference between appending an item and inserting an item at a specific index level in the list. So let's look at something else. Extending a list. So this is our list 1. Or let's define, okay, this list got modified. So we'll make another list 1. And we will say, let's say, Gary and we'll make another list 2. And we will say the so we saw earlier that if we were to append list 2 to list 1, it gets added as a full item, that is a list item, which will become an item within list 1. So if you were to just go up again, when we appended another list, so the appended list gets added as yet another item. But what if we want to add each of these elements of the list into the original list as individual items and not as a complete list? So extend will allow us to do that. So this we have list 1. And now I will do print list 1 and then let's do yeah. Now we don't see that the entire list is appended as an item. On the contrary, the individual elements of the list, which we're trying to append, those individual items of list 2 have got appended item by item into list 1.
Okay. So let's define a new list. And I will reverse this list. And let's see what happens if I were to print out my list now. So see, so all the elements of my list have now got reversed. Yeah.
But this process, it has also modified the entire ordering of my list. So if you were to now print out my list, which we've anyway done above, but doing it once again, it is not in the order in which it was originally, where the letters were 1, 2, 3, 4, 5, geek and Python. Now it's in the reverse order. So the original list has got modified in the process of reversing it. So is there a way that we can keep the order of the original list intact but at the same time, you want to print all the elements of it in a reverse order. So let's try doing that. Print the whole list in reverse order. So you see the difference here. I'm saying print the list in reverse order. I'm not asking it to reverse the list. So there's a very subtle difference here.
Yes.
So how will I do this? Now, so the way we can do it is, okay, let's print out what is my list now. Print out my list. This is my list. And now I just want to print it reverse. So I will say, and this is the syntax, colon, colon, I will do -1. So I want it to print it in reverse order. So the last index is -1, and I'm doing a double colon. Let's see what it is. Yeah. So it's printed all the elements of my list in reverse order. Now let's see whether this has ended up modifying my list. No. So my list remains intact. The ordering remains intact. I've only printed all the elements of that list in a reverse order. So that's the key difference between the reverse method and just printing out all the elements of the list in a reverse order.
All right.
Count the number of appearances So let's print my list. Now, let's say if I want to know how many occurrences of a given item are in my list, so I will say that list name dot count, and I will and the item for which I want to check. So let's say I check for 33. What do I get? 0, because there's no 33 here. But what if we do this? My list dot append 33, and now check the count of 33. So this way I can check how many occurrences of a given item is there in the list in which we want to check. And that one, it will, I want to know that in list 1, where does the item 33 appear? So it's giving me the index. It's giving me the count, and it's now also giving me the index where it appears. All right. Let's sort items in an ascending order. Let's define a new list. 13, 15, 0, minus 5. So all I need to do to sort in an ascending order is a method called sort. And now I'll print out X again, or I'll return X again, and it is sorted in an ascending order. Now let's create copy of a list. So I'll create a variable called Y, where I will create a copy of list X. There you go. And we already saw this yesterday, but let's quickly go through it again. Summing all the elements. So it's print sum and we pass the list. And we can similarly also do a max and min. So we will print the maximum value in the list X and also the minimum value in list X. There you are. Now we will look at something called enumerate. So let me write down what it will do. So it will come in handy as a note for you. So enumerate basically returns an iterator, which is a tuple. So when we ask for its next value, it returns a tuple. Just let me make it a markdown cell. It returns a tuple which contains count and the corresponding value from the sequence. So what does this really mean? So I have a list and I'm trying to enumerate that list. What it will do is it will create a tuple. So let's print out a list here. We already have a list here. Let's print Y. Now, what I want to do is I want to enumerate all the elements of Y. So it will basically come out as index value and the value corresponding to that index, which we call count here and the value corresponding to the count here. So how will we do this? It will become very intuitive once we do it. So let's create another variable called Z, which will enumerate all the elements of Y. So we created a new enumerate element. And now I will do print Z, print next Z. And I will keep repeating this and let's see what comes. Yeah. So what it's doing is at every step, first I've enumerated all the elements of Y, and the way it enumerates is it gives a count, which is the index and the value corresponding to that count or index. And every time I do next, it will give me the next tuple. Is this intuitive?
Yes.
Okay. Now this is getting a little boring because we're just doing a unidimensional or a single dimensional list. So let's create a multi-dimensional list. Anybody, any ideas as to how we can do this? So let's go with the structure first. I will define the variable, the list variable. I'll create a list object with this notation square bracket. And I want to create a multi-dimensional list. So what I will do is I will have list elements within the list. So let's say I want to keep 3 list elements here. So within the list, we have 3 elements and each of the element is another list element. Now let's populate those list elements. So let's say first is John and his marks, his grades. Second, we put another person and his corresponding grades. And now let's just print out new list. There we are. We have our first multi-dimensional list. Now, what we will do is you can also transpose a 2D list using a built-in function called zip. Let's try zip. So let's print the new list. We already have one list, so we don't have to make a new one. So this is a new list, okay? And we want to transpose. So the way we'll do this is let's create a new list 1, which will zip. We'll do a method zip star new list. Let's print this out. And now I will do yet another list element, which will capture all the zipped elements in new list 1. So just bear with me, I'll explain exactly what is going on here. And now we will print out our new list 2. So this here is transposing elements of the original list. And here, this command, this syntax is converting the transposed original list back into a list which contains values in a tuple, which contains values in tuples. So we created a zip object first, which transposed all the elements, and now we are trying to convert it back into a list. So you see, okay, let's just do a raw NB convert cell here and see what was the structure. So the structure of our original 2D list was like this: John 91, then we had Arun 98, Varun 99. But in the transposed list, this is the structure. You see the difference? All the names appeared as a column and the corresponding grades appeared as another column out here. Now that has got transposed. It appears as a row here, or rather the column headings, and we have the grades right under that. So that's how you can transpose a list.
Yeah.
All right. And we'll pretty much access the elements of a transposed 2D list the way we did earlier. So what is our new list? It's print new list 2. Now within this list, so what are we getting here? So in this new list, now we are again slicing and we are trying to get the grades of Arun.
Arun.
So what we are doing is we are going to, this is got transposed, right? So we are going to row 1. We're going to the first element. If you look at it in terms of tuple again, it's here. It's this is the tuple at index 0. This is the tuple at index 1. So we're going to the index 1 tuple, which is capturing the grades. And Arun appears at the index 1 in the tuple, which is at index 1. So we'll do new list 2, index 1, and we'll get the grades. Okay, let's amp it up a bit more. Create a seriously multi-dimensional list. So any suggestion on what kind of a list we can create? Okay, let me suggest, let's say we wish to record cycling distance of 2 cyclists for first 5 days of the week for 3 weeks. So what we are saying is, okay, let's take 2 cyclists who cycle the first 5 days of a week. Let's record the cycling distance for each of those 5 days for 3 consecutive weeks. So how will we create the structure of this kind of a multi-dimensional list? So since we have 2 cyclists here, let's begin with the structure of this should be that a list containing 2 cyclists like this. There's cyclist 1, there's cyclist 2. And each of these should be another list which will contain all the records. So cyclist 1 and his records, cyclist 2 and his records within a bigger list. So let's call it distance. And we'll create a list. Within this, we'll create list for 2 different cyclists. Cyclist 1, then we'll create another list for cyclist 2. Should be a comma here. Now we'll define cyclist 1. Right? And then we need to record the cycling performance of cyclist 1 for 3 weeks. So we have to, for each of the week, we'll create another list. Now we'll go to cyclist 2. And again, we have to capture his record for 3 weeks. So we'll create 3 containers, which are listed here. I hope the structure is clear to everybody. So we are here. The problem statement is we have 2 cyclists who cycle first 5 days of the week. You want to capture how long they cycled on each of those days for 3 weeks. So we have basically two sets of record. One is for cyclist one is for cyclist two. So we create a list. Within that, we have to create two lists, one for cyclist one for cyclist two. And for each of the cyclists, we need another three sets of record for 3 weeks. So we have first container, which says cyclist one, and then his record for week one, week two, week three. Cyclist two, his record for week one, week two, and week three. So this is how you can create a structure, and then it becomes very intuitive and simple. And now we can start populating whatever is the record for the individual weeks. So let's say give it 5 different values, 21, 22, 23, 19, and 20. 23, 24, 25, 18, and 19. And here we can say, let's say 18, 19, 20, 22, and 23. Like for cyclist 2, again, populate some values here, 24, 27, 18, 19, 23, 25, 26, 27. And let's try to print it out. Once again, I hope the structure is very clear to everyone. Okay,
Yeah.
so there's an issue here.
There's a
We make
comma missing after 23 for cyclist one.
Oh, yes, you're right. So this looks neat.
Yeah.
I hope the structure was very intuitive for everybody. So, we could have created this even in a different way, but here we have chosen that, okay, we will capture the record for the individual cyclist. So we create two buckets, one for cyclist one for cyclist two, and in each of the buckets, we'll populate the records for 3 different weeks. So this is how you can create a multi-dimensional list. Now let's try to splice this list. So how am I going to slice? Now I want for cyclist one, how much distance did he cover on the 3rd day of week 2? So cyclist one, I will index by doing 0 because it's the first index. So there are basically two lists within this list. There's a nested list. In the first index value, we have cyclist one, the record of cyclist one. So I'm indexing distance 0. Okay. And if you're, if you want to make it more intuitive, you can just do index distance 0 and see. All the records come out here. Okay. So we have the records for cyclist one. Now within this, I want to go to the records of cyclist one for week 2. So I will go to index value 2. Because index value 1 defines cyclist 1, then this is the index value 1 and 2. This defines the records for week 2. Now within this week 2, I want the distance covered on the 3rd day. That will be another index 2. Got it? So for cyclist 1, week 2, 3rd day, 25. That's how we can slice and we can retrieve specific record even in a multi-dimensional data object. Okay. Let's go to a tuple data set. So, tuple is very similar to the list, except that it is enclosed in parentheses and its elements cannot be mutated, cannot be changed. Now we'll check it out with some examples. So let's create a tuple, few tuples here. Let's say tuple 1 is Sam 7986. Let's say 2. Now I'll create another tuple 2. So tuple 2 is created by using parentheses. As you can see, those notations are very important. John. So these are two sample tuples are created. Okay, print tuple 1. Then I want to retrieve the first element of tuple 1. Then I want to retrieve the first and the second elements, or sorry, the second and the third elements, or from index 1 to index 3 of tuple 1, which we learned. So this is going to slice first to third element. Then here I will do print tuple 1 from index 2 onwards. Let's print these out. Yeah. So we've already done a lot of slicing. So the slicing here works pretty much like the way we learned slicing in this. Let's add some more components, even in terms of repeating the tuple or printing it out multiple times. It's pretty much like we did in the case of this. Let's say I want to print out tuple 1 3 times. It's the same. And I can do concatenate as well. So print tuple 1 plus tuple 2. This will concatenate the two tuples. Hope this is clear to everyone.
Yeah.
Let's try to understand what the difference between a tuple and a list. While we wrote in the definition, but now we'll come to the difference. Let's make it a markdown cell. What is the last list we had? Okay, let's make two tuple and list of identical elements. So we already have, okay, let's create another list one here with the same elements as tuple. List one, which will have all these elements of tuple. So now let's print list one. Then we'll print tuple 1. So they both have identical elements, with the only difference that one is within square bracket and the other one is within these parentheses. They are braced differently and they define different data objects. Now let's see what is the difference. I will mutate the list and I will assign a new value to the element at the 0th index. And I will say that the first element in list 1 should be Kevin. And now I will print out list 1. So the list 1 changes. So list 1 gets modified when I'm trying to assign a new value to any of its element, the list gets modified. and which we have seen even when we tried to do the reverse. Now let's try to do something absolutely similar with tuple 1. Tuple 1, let's take its 0th element at the index 0, and let me call it Kevin. Let's see what happens. And we will return tuple 1. Any guesses what will happen here? We will get an error. So tuple 1 cannot be mutated. The elements of tuple 1 of a tuple cannot be changed. A list can be modified, a tuple cannot be modified, and that is the main difference between the two. All right. We will come to another very interesting concept, which is called range. Okay, so here we have Python range. And let's say what Python range does. Python range. I'm already making all these notes for you so that they are ready references for you when you have the HTML files. So you can look back at it anytime along with the examples. So let's say Python range is an inbuilt function in Python which returns a sequence of numbers starting from 0, incrementing by 1 until it reaches the end number defined in the, or rather specified in the range. Just bear with me and it will become very clear. It's converted into Markdown. So Python range is an inbuilt function in Python which will allow us to iterate. And it defines a range where it returns a sequence of numbers starting from 0, incrementing by 1. So 0, 1, 2, 3, until it reaches the end number that we have specified in the end of the range. So let's see what does the syntax look like in Python. So a range will typically have a syntax like this: the start number, the end number, and the steps I want to take, or the hops. And the start number by default will be 0 unless or until it is defined. So start number by default is 0. So let's try to run it in a for loop. We just discussed for loop some time back. So let's say for x in range, start number 0, end number 5. And I'm not defining any steps. So by default, the steps are going to be 1. So there's a for loop for the range. And I wanted to print every number in the range. So once again, for every element in this range, as a number appears, I wanted to print it out. Is this clear?
Clear.
So once again, a Python range is defining a set of numbers which are starting from 0, which will increment by 1 until it reaches the last number specified to denote the end of the range. And it will increment by default by 1 unless and until we are defining a higher increment, which we can, by the way, here. Let's try to do this here. Now it's incrementing by 2 till the time it reaches the end of the range. So for every element in this range, we want it to do something. Here we want it to just print out that element. So that's how it is. And this will be very, very useful. Both for loop along with the range will allow us to traverse through very, very large CSV files, which can have like 3,000 columns, 10,000 rows, etc., which will be extremely helpful in data science. Okay, so that was Python range. Now we will come to a very interesting object called, or data type called dictionary. Okay. So what is a Python dictionary? So does anybody know what is a hash table? Okay, no worries. So Python dictionary is something like a hash table, and it consists of key value pairs. And since we are talking about notations of different data types, so dictionaries are enclosed by these curly braces like this. This denotes a dictionary data type in Python. And its values can be assigned and accessed by using these square brackets. We will see all of this one by one. In terms of properties, dictionaries are changeable, which means we can mutate them, which in turn means that we can change, add, remove items after we create a dictionary. So that's what a dictionary is, and those are the various properties. It's like a hash table. We'll go by it, and it's denoted by curly braces. So tuple is parenthesis, list is a square brace. Dictionary are these curly braces, and it is denoted with key value pairs. And the objects are mutable. We can change the objects. We can assign different values to different keys. Now let us understand this with an example, and that will also make it very intuitive. Okay, so let's create our first dictionary. I'm calling it mydict, and I'm giving it curly braces as we discussed. So what have I done here? I've created a dictionary object. Now, how do we assign key value pairs? So I'm assigning a key here as, let's say, name, and I'm assigning a value to it, Sam. So what it does is, what is happening here? Sorry. The left should not have a dot. The left assignment within these square brackets is what we call key. And the right assignment is its value. So this is how we define a key. So we first define a dictionary, and within this dictionary, we define an attribute or a key called name, and then we want to assign it a value. So we define the key as name, and we define its value as Sam. Now let's define some other properties. This is the name. I want the age. And the key should be within these quotations. Like I've said, name is in quotation, age is in quotation. The key is always denoted within a quotation. mydict. Let's say I want to also define the hobby, the profession, So we have defined multiple keys. Now let's go about defining the values. Let's say the hobby is playing guitar. And the job is banker. So we just created our first simple dictionary. Is this more intuitive to the list object that we created earlier? Wherein we had, let's say, different keys, not exactly keys, but let's say we had attributes and we had corresponding values, like we had students and their marks. Do you think this is more intuitive?
Yeah.
Everyone clear about this?
Yes.
Here, okay. We can also find the length of this dictionary item. And of course, let's see what it prints out as type of item. Yeah. Type once again refers to the data type of the variable object, which is a dictionary. So that's our first dictionary. Okay. Now here we had multiple lines of code. We can also define the same dictionary in a single line. So we define the key here, colon, its value, comma, second key, which is age, its value, third key, which is hobby, its corresponding value, and the fourth key, which is job, and its corresponding value. All of it neatly enclosed within these curly braces, and we define our dictionary in a single line of code. And here we print it out, or rather we return it. Same thing as above, but with a single line. Now let us try to create a dictionary for multiple people. So far we have kept it very simple. It's just for, let's say, one person in different attributes, different information about one single person. But what if we want to do this for multiple people? So let's create a new dictionary called dict1. And let's understand the structure. So first we are creating a dictionary object. Now I will define the first person as a key. Is, let's say, Sam. And for Sam, I want multiple information. So I will create yet another dictionary for Sam. And now within this dictionary, which is dictionary 1, within that there is a key called Sam. I want different information for Sam. So what is the first key for Sam? Let's say age. And I say this is 26. Same as before, but this time we are not limiting ourselves to Sam. We'll go to another person as well. Now we'll say 1. Again, key is Sam. And for Sam, we want more records. We'll have yet another key, which is job. So here we define the original dictionary object. Within that, we define a key as Sam, and Sam itself, we've defined a dictionary. So the value of Sam, which is a key here, is another dictionary because we have to keep multiple records of information for Sam, and we have to create other people as well. So we first begin with the mother dictionary. We create a key called Sam. We define it a value, we give it a value of a dictionary, and then we start creating other keys inside that dictionary to store different information about Sam. And we are going to do the same for the next person. So let's say the next person is, I'm just going to copy this and I've just changed the values and the key name. Let's say our next person is John. And the information we want to store for John are the same, but the values for that information will change. So let's say John is 25 years old and his hobby is football and he's a fund manager. So now we have created a dictionary with two different people. Let's bring our dictionary. There you go. So this is very clear. So we create a dictionary within which there is a key called Sam, and all the information or all the value corresponding to Sam is stored in yet another dictionary. Then we create another key called John, where we want to record all the information pertaining to John, which we store in another dictionary. So there are two keys. One key is Sam. Its value is a dictionary, which records all the information about Sam. Second key is John. Its value is another dictionary, which records all the information about John. And are these steps to create or to construct the dictionary clear and assigning the values? Is this clear?
Yeah.
All right, cool. So now you already know something very important, which is creating a dictionary. Just give me a second. So now can you, so this is also a nested dictionary. Now let's try to extract some information. Let's say I want to know what is Sam's hobby. So how will I slice this, or how will I extract Sam's hobby? The way to extract information out of a dictionary is first you define the key where that information is stored. So I want information about Sam. So first thing I will do is I will go to Sam. So dict1, my key is Sam, where all the values are stored. So all the values corresponding to Sam is here. Now within this, what do I want to know? I want to know what is his job. So job is another key. So within this, I will define another key called job. So Sam job, and it will give me the result. So isn't this a lot more intuitive than the nested list that we were trying to create, where probably we had a person and we had different information and we just had to go by, okay, like we had in the case of cyclists, records for 3 different weeks, and then we had to go for cyclist 1, week 2, third day, and we had to memorize, what was the position of the record for each of the week, and what is the position of, let's say, cyclist 1 in terms of the index in the master nested list. Out here, it is very intuitive. We just go by the name of the key and the sub key, right? So the main key is Sam. Within that, the sub key is job, and I get the value corresponding to that.
Yes.
Cool. Now I'll go to, let's change it. And let's say I want something about John. I want to know what is John's hobby. So the main key is John, the sub key is hobby, and there it is. A lot much more intuitive. And just like we did for 2 people out here, now imagine instead of age, hobby, and job, we were to record the scores, the class grades, marks. of different students in a class, and these subjects were, let's say, physics, chemistry, and maths. So let's say in a class we have 40 students, so we'll have to create 40 sets of record. Each record will have its value, which will be stored in a dictionary, and each dictionary will capture the marks of physics, chemistry, maths. And at any given point of time for a particular student, if you want to find out what are the grades, we just probably would extract the information by typing the name, by typing the name of the student, and we'll get all the record corresponding to that student. So dictionary makes it a lot much more intuitive to capture what we call nested information. Okay, so let's say we have dict1. If we just want to retrieve at any given point of time, this is a simple dictionary, but let's say if it had, let's say 5,000 such records, and we want to know that, okay, how many records does it really have? Let me give you an example. Let's say for a particular municipality, it had the records of all the citizens within the confines of that municipality. And, I'm doing some kind of a statistical analysis at a very basic level. I want the information, how many residents are there in a given municipality. So what I will do is I will go to a dictionary which contains the information about all the residents of that municipality. I will do keys, and it will show me all the keys which are there. Similarly, I can say extract all the values. Yeah. The first one extracts the key, second one extracts the values. Okay. Now we'll go to something called sorting a dictionary by values. Okay, so here we will import a library called NumPy. You don't need to understand what is NumPy right now. We will cover it later as another full section. But we will be invoking one of the functions within NumPy to do this operation, and it will be very intuitive. So let's create a new dictionary here, and it will be, let's call it marks. And I construct a dictionary, and I put the names of 3 students. Alia, her grades. Second key is going to be Varun. And yet another student called, let's say, John. And now so here we create a very simple dictionary, but it's not sorted by values, right? Ideally, it should be Varun, which is lowest, then John, and then Alia. So here we will try to sort it by values. So first what we will do is we will extract the keys, and we'll put it in a list object. So we'll make a list object of the keys. So marks dot keys. And yeah. So here I'm extracting all the keys from this dictionary, and I'm converting it into a list object, and I'm storing it into a variable called keys. I will do the same for values. All right, so I have this. Let's print out keys and values. Let's print values also and see what we have. Okay, so we've extracted keys in the form for list, values under values. Now we need to sort it. So here we'll do a index sorted by values, and we'll give it the name of a variable called sorted value index. And we'll run an operation by invoking a function within NumPy library called argsort. What this is doing here is it is sorting the indexes by corresponding values. So here we have sorted index, and now we have to rearrange the dictionary by using the sorted index. So now create a dictionary which is sorted by values. And the way we will do it is we will create curly braces. We will define keys. We already have an object here called keys, which is storing all the key values, all the values corresponding to those keys. So we will say keys I colon values I for I in sorted value index. What this is doing here is, here we have the sorted value index. So we've taken the values, and this is running a function which is sorting and arranging the index in an ascending order by the corresponding values. Now we are trying to create a sorted dictionary where it will take keys and values by the corresponding indexes which are in the sorted value index, and see how it rearranges the dictionary. Let's try to print our new sorted dictionary, sorted by values. There you go. Is this clear?
Yes. Yeah.
Everyone, I hope this was clear. And I've made these notes, and you can probably go through the video recording a couple of more times if you need to. But the whole syntax in Python is very intuitive. If you go through it a couple of times, just the English itself in the commands becomes very intuitive.
Okay, so
Okay, let's do one exercise. Let's create a dictionary containing subject scores of 3 students. We'll keep the same 3 students, but this time we will have a variation. Earlier, we just had one single score for each of the students. This time we'll have their scores for 3 subjects. So it should be something like this. Like you have Alia, and you have a record for, let's say, maths. She got 96. Then you take physics, 97. Then computer science, 98. Right, and then you have Arun. $95. Let's take something for physics. And for CS, let's say some score. And finally, we have first student. So this is a problem statement. So this will again become a nested dictionary. So let's understand the structure and how we will approach it step by step. So what will be step one? So let's give a name to our dictionary. Here we are trying to capture the class for the 3 students. So we will define our dictionary as a dict object within curly braces. Step 2. We will define your keys and assign dictionaries to store values corresponding to those keys. So class course, there's Alia, and all the record of Alia will be stored as another dictionary. So this will become a nested dictionary. We'll score other records, other keys. Scores another key called Arun, and all the grades, all the marks of Arun will be stored as information in a dictionary corresponding to the key Arun. And class scores another key called Varun, third student, and get another dictionary. Let's see what our dictionary currently looks like. Okay, so we have a nested dictionary wherein we have 3 keys, Alia, Arun, and Varun, and we have values corresponding to them, which are empty dictionaries. So now let us populate those values like we did earlier. So we'll have class course, we'll take the key, Alia, and let's populate her marks. So the first key within the dictionary corresponding to Alia will be maths. And let's assign a value to it, which is 96. Now I will just copy this to reduce my typing. This is some reductive programming, trying to reduce my typing. So maths, physics, and the third subject is CS. Okay, let's assign a value to physics and to CS. Sorry, it's and you might want to just keep seeing whether we are on the right track by checking what your dictionary looks like at intermediate steps. So fine, I want to check this. Fine. So my original dictionary, which had the 3 keys, I've already populated the values of the first key. Now let's go on to do it for other keys. So now I will do some more reductive typing. I will do a copy paste. And I will just change the key values. And the second key value is Arun. And the scores corresponding to Arun are 95, 92, and 95. And now I will do the same for Varun. Now let's print out our dictionary and see what it looks like. Is this clear? Okay, no, there is some mistake. Why didn't we get, okay, we did not run this. That's why. Is this clear now?
Yes.
So clear to everybody how we create these nested dictionaries. And this is so much more intuitive. You can have, let's say like this, 800 students in a particular school, and you can create nested records for them for each and every class from class 1 to class 12, and in each class for different exams for different subjects. And the structure pretty much remains the same, and we can create more and more and more nested loops within this dictionary. All right. So this is good. Okay, so we have covered quite a bit. Now I would like all of you to do an exercise on your own. So does everybody understand the structure of going and creating multiple layers within a dictionary or dictionary within a dictionary? Yeah?
Understood.
Yeah. Okay. So we are pretty much to the end of this class. What I would like you to do over the next 1 week, and which I will email to you as a problem exercise, I want you to create a family tree. And the problem statement runs something like this, right? There's a guy called Sam, and he's an 85-year-old guy, and we have to plot his, what, 3 or 4 generations. So Sam has a son and a daughter. The son is 60-year-old and he's a banker and he earns some 500,000 USD. He also has a daughter who is a 35-year-old. So here we are talking about the original Sam, Sam's son. We are going 1 tree level down into the branch. Son who's 60-year-old and all his information, and the son who in turn has a daughter who's 35-year-old, who works as a techie and earns 100,000 USD. And she in turn has a son who's a 10-year-old, studies in class 5 and has a hobby of playing chess. Now Sam, let's go to Sam's daughter. So Sam, we have 2 tree branches. Okay, let me just try to plot it here as best as I can. And then we'll have to construct an algorithm, and based on that algorithm, we will have to do a code. All right, okay, so let's see how this works. So let's say we have a patriarch called Sam. Sam has a son and a daughter. The son is 60 years old. Is a banker and earns 500K. Now let's go to the next branch in the family. He has a daughter. She is, let's say, 35 years old. Is a techie and earns 100K USD. And guess what? She has a son who is 10-year-old studies in class 5 and plays chess. Now let's come to the daughter. Daughter, let's say, is 55 years old, is a teacher, and she earns 600K. And this daughter has a son who is, let's say, 30 years old, is a musician by profession, and earns 80K. And he, in turn, has a daughter. Who is, let's say, 7 years old, is in class 2, and she has a hobby of playing Lego. Now and Sam is 85 years old. Now we need to create a nested dictionary to capture this family tree. Simple? Okay, no problem. So you'll have the entire week to do this, and I'll catch you again next Saturday. All right. Thank you, everyone.
Thank you.